Welcome back to VTU e-Shikshana program on engineering drawing, actually computer aided engineering drawing. Now we are in module 2, working for different solids. We have already worked out triangular prism, rectangular prism and pentagonal prism, square prism. Now we will work out a problem on pyramid, particularly square pyramid now. Now we take a problem on square pyramid. The pyramid actually has the base side 40 mm and 60 mm height. Has its base wedge, one of the base edge on the ground RHP, and the axis inclined at 45 degree to HP. Draw the projections. When I have taken three cases, let us discuss one by one. When the base edge on HP is inclined at 30 degree to VP, and the axis is again, already it is inclined to HP, again it is inclined to VP by 30 degree, and the axis appears to be inclined at 30 degree to VP. Same type of questions we have already discussed for prisms of square type and the pentagon, etc. Now let us work for the pyramid. Now, so I take a pyramid. This is base surface and base edges and base corners. And if I keep this in a standard position such that one of the base edges is parallel to VP or one of the base edges is perpendicular to P. It's a characteristic feature of square. Two base edges are parallel to each other and then it is also parallel to VP. Now these two are perpendicular. If I keep a solid on the HP like this, now the one of the base edges is perpendicular to HP, perpendicular to VP. In fact, it is on HP. Now, if I tilt this in this way, first position, second position, what happens? The base of the solid is inclined at some degree to HP, or imaginary line, that is axis, which is perpendicular to the base, is inclined at some degree to HP. Or we can refer the same information with respect to the slant face. The slant face containing the base edge on HP is inclined at some degree to HP. Instead of axis, we will get that type of question also. Okay, situation. First position, second position. Anyway, the axis is inclined to HP or base is inclined to HP. So, first position, second position. Suppose that if we keep it like this for this problem, what happens? Let us see. Corner on ground. So, that's why always I say the base edge to be placed on HP is always perpendicular to VP. First position, second position. Then we will look for three cases. First case, the base edge on HP, this one which is on HP now, is right now perpendicular to VP. Now we have to give inclination to VP by some angle, that is given 30 degree to VP. Either this way or this way. If you do like this, base is not visible. If you tilt like this, base is towards observer, definitely base is visible. Okay, now we will take up that in the second stage. First stage is the working of the projections of solid with initial position when the base is on HP or axis perpendicular to HP. First, to get the true shape of the base of the pyramid on HP. And like the prism, we have cross section is same. Here it is reducing or increasing as you move from base end to the vertex. Now, first position, what is top view? Square. Second position is apparent shape. That all we get after projecting it. Now, let us work this particular position. Okay. Now, the top view is the true shape of the base. Now, we will start like this. Axis condition. Axis inclined to HP. So, make it perpendicular to HP to get the true shape of the base of the pyramid on HP. Next, what is the orientation? So, can I keep it like this or in this way? Again, it is edge or corner condition. So, edge condition is the edge to be placed on HP is always perpendicular to VP. So, this is the first position. So, in this first position, what is top view? Top view is a square. So, let me draw first the axis, XY line. so that you can start the top view. So XY, VP, HP. So the top view is square such that one of the base edge is perpendicular to VP, so that the edge on HP. Now assume that this is the dimension I have, assume that it is 40. Now keep this neatly. If it is computer, you will get rectangle by 2 points. You can fix both dimensions same, 40 each, so that you get the required figure. Now this is A, B, C, D. How to get the front view? To get front view, we need the apex to be identified. Top view is not completed now. Unlike prism is the midpoint of the prism. The top view gets you the center of the top face. Here it is different. You are getting this slant edges. Top view of the slant edges. This must be in dark line. Okay. So let me use this dark line, and before that let me name V in bracket O. Always you refer V for all pyramids and cone. I will tell you why. What is the reason? You can keep O also. Always you better keep V so that you get the top view. Ready now? So it is very important stage where we commit mistakes normally for all pyramids. See, this we keep very light. When you look from the top, all these clear-cut edges, that is slant edges, are to be mentioned, identified as dark lines, visible lines. Okay, these are all visible lines, okay, actual edges. Now, the lines which are to be marked are these. It's very important. This must be dark. This is very important. In case of prism, we never do it. We keep only thin lines just to represent the center point. Now project this. So this is A dash, this is B dash, C dash, D dash in bracket. Now axis. Identify the axis, thin line, and then here assume that I am taking the axis reference. Nothing is in front, neither the hidden edge or visible edge. You can fix the apex and axis. So dot this. In one go you can keep. You not draw thin line and then dot. So directly you can keep, because these are all the visible edges in front of you. So this is again important. This represents the base. Even though base is not visible, suppose that this is the lamina, square lamina. If you look from this, you will get a clear-cut edge. Here, this one is visible. All are invisible. So it is coinciding with that. Now VO. This is V. This is O dash. So this is first figure, top view, front view. Next, what happens if you get this? Change the position. Axis is inclined at 45 degree to HP. Okay, this is 45 degree to HP. In case of prisms, we will have the extreme line as the line parallel to the axis. If I take the inclination to this extreme line, either it's longer edge or the slant surface, the lateral face representation, that assumes same angle with the axis. But here it is actually slope. We have slant face. we don't have the parallel line. So what I do is, manually if you are doing, you keep axis inclination converted into base inclination. Now, so axis inclination plus base inclination is must be total 90. Here this is given, so theta b equal to 90 minus theta a. So naturally this is 45 degree. If it is 30 degree, then it becomes 60, and also 60, then you get 30 or 50, 40, whatever the number, you must be very careful to it. Now, how to redraw this? I will take the base reference, not the axis now. If I take axis, then I have to manipulate this angle, etc. It's very easy. You keep this first, 90 minus of axis, definitely you get the required inclination for the axis. So if I get the inclination to the slant face directly, it's no worry, can take directly. Anyway, let us work such problems also in future. Now, take base inclination 45 degree, so that you get the inclination for the axis 45 degree only. Now keep this, assume that I am keeping the 45 degree line approximately, then get the line. So I have fixed the base. So this is B dash C dash, this one is A dash D dash. Now take the midpoint and keep, this is O dash. Now how to rewrite? It's very easy job. There are two ways of working. You take this distance equal to radius, draw two arcs, or best thing is keep this perpendicular line, that's all. Now you can use protractor, or if you have any other instrument, you can directly keep the perpendicular line and then draw the axis line first. Assume that I am keeping the axis line and keep this distance, whatever you have taken. So that is 60. In this case it is 60. Join these points. So because we have given inclination to the base, automatically it takes the inclination to the axis also, but you have to dimension to the axis only, because given value is for axis. Then mark dark line for the base also. So this is second figure front view. What I did, I have redrawn this figure such that base is inclined at 45 degree. In turn, the axis also assumed 45 degree. If base is 60 degree, I could have taken this as 30. Okay, and vice versa. Now, the second figure top view is by projecting this. See, I am keeping only this line and the lowest line. For all pyramids, don't worry about the apex. Unnecessary lines you can avoid. Now draw this, that's all. Now this becomes your C, this is D, this is A, this becomes B. Now why I have not drawn up to this? Because sometimes every line will be up to this point, not necessarily. We have this only one projection, that is from V, which will take care of apex in second figure top view. In case of computer, alignment indicator is there, you move this, touch this one and then get it. That is easy for you now. Okay. After this, what exactly you have to do? Keep this line joined with all corners. All these apex points must be joined with the corner. Yes. This is center, identify the center. It's a very simple problem, but it is very important problem. If you understand this, you can work any problem on solids. Now, I am here. I have to complete this projection. There are two methods I told you. One method is farthest item from you. you identify and proceed, or key surface method. So let me, easiest thing is farthest item method only. Let us work. Whether any confusion, then we will shift to the key surface method. Identification of visible key surface, then proceed. Now here the observer is here. Here this is the farthest item from the observer. What exactly this? This is base edge B1 C1 on HP. So this is the thing which is farthest item from the observer. This is not visible in top view. Yeah, let me keep this dotted. That means this item is not visible. Yes. Next thing is any number of lines joining this item, corners. In case of edge, the two corners you have. In case of just corner, you get only imaginary point there. Whatever the number of points you get, that you know, previous problems we worked. Here these two are the points, reference points. Any number of lines joining this item are not visible. That is procedure. But here these are boundary lines. However, boundary lines are always dark. So only, again, these two are dark, these two are dark. These only 4 lines are joining that. All those 4 lines are boundary lines. We have decided to have that as dark line. Then this is the only line which is not visible. Then rest of the lines are dark. All remaining lines are dark. So easy job now. Dark all lines joining apex. So that covers boundary also. You can check all boundary lines simply dark, okay, irrespective of the situation. Now, so somebody may have doubt what exactly this, whether this is visible or not. You can go back to crossing lines. Crossing lines. Already this line is visible. This must be different. That is visible line. Invisible line, visible line. Now again this one is crossing line. You can review that. If there is any doubt, you can also use that concept. Yes, that's all about the second figure top view. We got second figure top view by locating the farthest item, and we have made that not visible, and any number of lines joining that line are not visible, but all are boundary lines. Yes, again that is dark, and all rest of the lines are dark. We have made all the lines dark. Now rest of the thing is the VO. What is VO? Imaginary axis line that must be 0.25 or 0.35 in computer. Here it is thin axis representation, thin line. So that's all. This is second figure top view. Next, let me take case 1 in this particular problem. What is case 1? Case 1 is the base edge on HP is inclined at 30 degree to VP. Which is the base edge on HP? This is BC, not B1C1. This is BC, and like it's prism, it's B1C1. The BC is the edge, base edge on HP. This is inclined at 30 degree to VP. In third figure top you have to execute this. How to do it? It's a very simple job. In computer you move this and rotate such that BC is inclined at 30 degree to XY. So as usual, the XY HVVP we have drawn. Now, so assume that this is the figure I have. Assume that this is the figure. This is BC somewhere here. This is BC. Keep it like this. So BC must be inclined at 30 degree. So here no question of beta, because BC is true length. So it is 40. This one is 60. Okay, 60, 40. This is, here we have apparent shape for the base. The 40 square becomes the rectangle now, and this BC is representing the base edge on HP. This is perpendicular right now, I am interested in keeping that 30 degree. So how to do it? Manually draw a 30 degree line. You can have two options. One is base is towards observer, base is away from the observer. If you want base is towards observer, you tilt this way. Let V go here and then base nearer to you. Now let me do like that only. To start with, let me keep 30 degree line. Okay. So keep 30 degree line. Assume that this is 30 degree line, thin line, and then take these things, draw this line. So assume that this is BC here, I am keeping BC. This is actually dotted line, not visible according to this. Let me highlight what I have done. This is BC. This must be inclined at 30 degree. True length on true inclination. True inclination here, because there is no beta. Now how to take this figure? You can just draw geometry. Okay. Now that's all. Whatever is there, I have redrawn. Now meet this portion, keep this way. Draw a line, better. Draw a line. Place this here. Again, take total distance, or from this, take this distance. That's all. It's very easy to redraw. Simple geometry. Now join this. Unlike pentagon, hexagon, this is not troubling you much because of less number of corners and sides. Okay. So whatever is there, you should keep dark line, thin line, etc. Yes. So I have made this axis OV. This is A, this is B, C, D. I repeat, BC must be inclined at 30 degree to VP. This is true length, that's why I have taken true inclination. True length always associated with true inclination. No question of beta here. So I am repeating because people ask frequently, when you take beta, is it necessary to take beta? No, just true length and true inclination. Next, how to get the final front view. So I will show you how exactly this happened. First position, second position, third position. I have made base little dark so that you can realize base is visible. Okay. So first position, second position, third position. Now let us take the concept of farthest point from you and discuss. Then also discuss the same problem with the key surface method. Okay. Now I am here. So which is the farthest item from you? V, apex. As per the procedure, whatever the lines joining this apex are not visible. Okay, but there is one class, terms and conditions apply, say all boundary lines are visible. Then we have to see what exactly is the solution for you. Now let me complete this by projecting the points. First let me take CB is very much on HP, this is C dash, this is D dash. You not project unnecessarily. This is AD locus. Project AD carefully. Okay, this is D dash, this one is A dash. So what I did, I projected base surface completely. All four base edges are available in front view. Now join them in order. Okay, keep it light only. Let us discuss. Don't be in hurry always. Okay, now this is V dash, this is O, O dash. So everything is available in front of you. Now let me start working for the boundary and related lines, edges. All thin lines. Let me keep first all thin lines. Okay. Sometimes these two may coincide. Here assume that right now these two are different, slightly different. Okay. Now I am here. The farthest item from you is V. V is not visible. All lines are dark, dotted. I always say, sometimes only boundary lines are dark. What about this? So then we will landing to the confusion. So surface method is always better. Key surface method. Best thing is, see, first position, second position, third position. Which is the nearest key surface to you? Only one key surface I have here, unlike prism. So this key surface is, I have made it dark color. So this base surface is visible. That's the only criteria I need. Automatically you will get the solution. Now I hope you understood, all of you understood what exactly I mean. If I take farthest item from the observer, this is the V, and all these lines becomes dotted. At the same time, the boundary lines I have given a one more class, only boundary line, however boundary lines are dark. Yes, these two becomes dark. What about this? So to avoid any confusion, what I do is, I take key surface method and then fix this base is nearer to you. So base is visible. So let me start working. It's very easy and interesting. So base is visible. Yes. Then boundary lines completely dark. Basic procedure is this: visible key surface dark, number one, procedure one. Number two, completely boundary lines are dark. Irrespective of the situation, boundary lines are dark. Okay. Next, after this, invisible surface. I don't have invisible surface here. Only one key surface. Now, the crossing line and the Benz reference is available with us, and also fundamental concept: visible surface, invisible line, invisible surface, visible line. Now let me use the fundamental concept. This is visible surface. Line joining C dash B dash is absolutely invisible, dotted line, because this is the surface visible. You cannot have. See here, I will show you this. All these are dark lines, black color lines, say dark lines. This is dark color, yellow, dark yellow. Now this surface is visible. Can you see this line? No. So the surface is visible. Through that surface, any line is crossing. Okay, on the projection, whatever we have drawn, light line are not visible. Not only that portion, not only the complete, till it ends, that edge. Because sometimes I have seen people use only that portion and then said, this is only, no, it's completely, you cannot see anything here. Till this is, that particular line is covered with the front solid surface. So this particular line is not visible. That means visible surface, invisible line, or we can always say crossing line. Easy. Next, this particular point A. What do you complete? See, this is the symbol I have, Benz. I can keep this particular point as a reference. These two are dark lines. One more line joining that also dark, because it is Benz. Okay, I don't have invisible surface, so to say this, the only thing is Benz. So I have completed the all slant edges and all four base edges. The left one is the axis line. You can easily complete. Yes, this is O dash. Okay. Now, I told you why we use V, why not O, etc. So, in some cases, people confuse this O with the one which they have already identified. So, what they do is they will project this only and get this point somewhere here. Okay, they forget this because O confused. So, that's why I always keep this very clear cut information vertex. So, I use vertex. You can keep O and do it neatly, no problem, no objection, but always prefer to keep V there. Now, first position, the surface of the base is on HP, and next base edge is on HP perpendicular to VP. Now I have given inclination to VP like this, or I can give like this. Now I have given here. Let us discuss on computer software this type also, how what exactly you are going to get. Easy to interpret. Okay, so this is how you solve a problem on pyramid. It can be any type of pyramid, triangular pyramid, pentagon, hexagon, anything. That all depends. If I suppose that it is triangular pyramid, edge condition, you get this type. Start with initial position. Okay. If it is square, already we have this. Then if it is pentagon, okay, this one is the reference. If it is hexagon, same procedure, no change. See, all are same. Only thing is for prisms, you get only plane surface. For pyramids, you get slant surface included here. Okay. You have to draw slant edges, dark lines like this. Otherwise, that is general information for base edge condition. Okay. If it is corner condition, again, say this is XY, this is for triangle, and diagonal passing through the corner to be placed on HP is always parallel in case of even number of sides. If it is pentagon, it's like this. One of the opposite side to the edge corner to be placed on HP is always parallel, or median is perpendicular bisector parallel. Here it is median. Now, if it is hexagon, same thing. So, this is parallel. So, this is how you can use same concept to solve any shape for information. Now, let me take up this. The axis is inclined at 30 degree to VP. What you do? You forget about this BC now. The criteria is the axis reference for the second case. Second case, OV is apparent length. So, in this case, OV is apparent length in second figure top view. O is apparent length second figure top view. Now, what you do? You have to keep it on apparent inclination. So, find beta. So, AL on AI, find beta, because we don't have the apparent angle here. So, what you do is, you forget this reference, you take up OV only and make this beta. You find out beta, different place or same place, and see that will be on beta degree line, OV, beta degree line. So, I will sketch this here, simple sketch. This is V, this is O, it should be on beta. Find beta and identify that and redraw the figure like that. Next, last question, last case, axis appears to be inclined at 30. So, beta is given here. Beta is given, that is equal to 30 degree. So, straight away you keep this case 3, this is case 2, keep this VO on 30 degree line, that is given directly. So, do the same procedure, you will get the final position as this, almost similar to this, small variation will be there, you will get the final front view. So, this we will discuss on computer software. Let me take problem on square pyramid. A square pyramid of 40 mm base sides and axis 60 mm long has one of its edges, base edges particularly on HP, such that I have taken 3 cases. So, the axis inclined at 45 degree to HP and the base edge on HP is inclined at 30 degree to VP. This is case 1. Case 2 is, as I explained earlier, axis inclined at 45 degree to HP and 30 degree to VP. Then axis is inclined at 45 degree to HP and appears to be inclined at 30. This is the three types of problems you may get. One of the cases will be included and gives you a problem. Now, so as I explained earlier, you have the top view, front view. You know in laminae how to draw the top view in case of edge condition. There you used to take this one as the reference, AB, AD as the reference. Now I am taking BC. Actually, you have to move forward by inclining the solid. So I always say BC. Even you can take AD, but you have to do ulta, back side. So by default, always you take the BC as a reference, the edge to be placed on HP. Then see here I have drawn two lines crossing this. This is actually diagonals. They are not representing diagonals of the base. They are representing the slant edges. Okay. So we have seen the solid and also you are familiar with that. Four slant edges are there. The lines joining the apex and the base corners. They are referred to as slant edges or longer edges. And the associated surface is triangular face. In case of prisms, you get rectangular face and longer edges and lateral face. Now, this is the front view. So, you project only onto XY line, you get the base projection and then join all corners with the apex with a given height, 60 mm height. You take from the center, you project and then get the thing. Now, after getting this, let me consider first case. Okay, till completion of second figure, it works for all. Now, then you try to move and rotate. So you are familiar with how to move and rotate. Then but here I will show you particularly how to move and rotate so that you are acquainted with that, because I am considering base as reference normally. So what you do is you try to select this. Select this, move, because the dark shade is there, because we want in both sides. Yes. Next, you have to rotate this such that this becomes a 45-degree line. But suppose that this is, say, if he says 60 degree, you have to take for the base 30. So 90 minus of given value. Now, since he has given 45, it is easy, both are 45. So go for inclination, that is rotation. So here it's better to have base reference and then rotate. Okay, it's easy, base. So as I told you, 90 minus of that, it is 45 here. So and see that this is blank, not shaded, so that you should not get the original one retained. So this is 45. Okay. Now check for the angle, directly axis. Yes, it is 45 degree. So 45 degree. Now we can proceed with the second figure, top view. Now if you have any problem with the space, you can take this back again by using move command. You take this back. So this is how you can work a problem, move first and then rotate for the base, then automatically you will get for the axis. Okay, now project it. So you project only base first, then single line works for the apex. You need not project all the points up to this overall area. Okay, identify A, B, C, D as the base corners and V, O. Now join V with all base corners with light lines only. I will tell you what exactly this. There are two methods I told you. Already I have discussed that. Now, after getting the light lines, now how to complete the here the farthest item concept works well. Okay, you are here, then the farthest item is BC. BC is not visible. Any number of lines connecting to that are not visible. Basically, CD and CV and AB, but they are boundary lines. So you have to retain that as dark lines. Okay, next, rest of the lines all are dark. So what you do is first keep this dark line and then keep all the lines dark. So here Basically what you have to do is, first I will show you how exactly you do it. Select this, and since you are getting complete line as a reference, now you make this uh, split this at this point. Okay, then you convert this into dotted line. Okay, so select that and convert that into dotted line. So 0.5 and then dotted line. Yes, got this line, dotted line. Now boundary line is completely dark. Okay, this line. So these lines become, because they are boundary line, they are dark. Next, rest of the lines are completely dark. These two, again, only these two are left out. They are also dark. These lines are dark. Yes, that's and the key surface method also I can use. See, you are here. Key surface is not visible. Boundary lines are visible. Fine. Then invisible key surface edges other than boundary lines are dotted. Yes, only one line, because these three lines forms boundary. Then how to complete these two? Crossing line. So our invisible surface, visible line. Okay. So it's very easy to do it. Either method you can use or part you can use. Crossing line, bends. You can check with crossing line or bends. Okay. Boundary lines always dark. Next comes the again giving inclination to the base edges, that is BC 30 degree, as we did earlier. This is how you can do it. Move and rotate. Next comes projection of all these corners along with O, that is base center, and V to fix the axis. Okay. Now join ABCD first and then see that all ABCD are joined with apex. Then these things are very light. Now you look from this direction. Which is the farthest item from you? Apex. So apex. Any number of lines joining that apex are dotted. So problem is you get confused what to do. But you have to apply again boundary lines dark, invisible surface, visible line. Then for this particular cases, key surface method is best. Which key surface is nearer to you? Yes. Base surface. Yes, base is visible. I will do that. Here only I will do it. Now base surface is visible. Make all these. Let me select those and then make all these dark. Visible key surface edges dark. I will use different color for information, because, and also little thickness, so that final solution I will show you different. Now let me use say what I have done. Visible key surface dark. This is for explanation only. Colors and all I am using. Now after you complete the visible key surface, then go for boundary line. So boundary lines are these: DV and VB, V dash, B dash, V dash, D dash, and these two lines already we have darkened. So select those two. Procedure, basic procedure 2 for this method, key surface method, is the I've taken 1.4 and magenta. Yes. See, I have drawn this. Now, what next? After no other key surface, because it is only pyramid, only one surface is there, base. And next you go to either crossing line or bends or visible surface, invisible line. Now you just say this is crossing line from this, or visible surface, invisible line. Now I will again give you some idea so that you can also do experiment at home. Select this very light surface, yeah, very light surface, and select this also very light surface. Go to shade and then select this. Okay. Yeah, part by part it will come. Yeah, see what exactly happened. Visible key surface. Through that I have a particular edge, CV edge crossing this surface. So visible surface, invisible line. Not only up to this point, not only till this, you cover this V. So what is the outcome? Now visible surface, invisible line. Now what about this line? There is no invisible surface here. It is clear cut bends. This line is visible, this line is also visible. Definitely one more line is joining, that also visible. Okay, or you can have imagination, the surface is nearer to you, that particular corner is visible to you. Definitely that corner and joining line with that corner and apex are visible. But that and all needs sufficient imagination. Okay, otherwise this bends works for you. AD is line and AB is line with this Benz notation type. AB is also visible. These two are visible, then this is also visible. So take that and make that as visible. So dark that. Okay. Now much confusion. It is only for understanding purpose. This shading and all, you are not supposed to do it. Okay. So what about this line? This line I have to select. This line I have to select and make that dotted. Let me use different color for understanding purpose. Let me use red color. Yeah, red with the thickness 0.14. Yeah, see, just observe here. So this is Benz. Okay, we take same color. Yes. Now you see visible key surface dark, boundary lines dark. Okay. Then crossing line. This is Benz. That's all. Okay. Or visible surface, invisible line. So this is how you can complete the solution, but not with colors. Just you keep black and white. I have done one by one. See what I have done. I have made only this one dark. Then I have made the boundary dark. Then the rest of the two is, this is Benz and this one is again crossing line. Okay, so very easy job. Now this is the final solution for the problem case 1, the base edge on HP is inclined at 30 degree T. Next case is when the axis inclined at 45 degree H. So as I told you, you have to find out beta, because VO is inclined to both HP and VP, hence find apparent angle beta. So OV1 is true length and VO is apparent length. So you know how to proceed with this. Then you move and rotate such that this VO is on this line. Then procedure same thing. So you have to take. Now how to find beta separately, you do like this. First you take the true length and draw locus. Then take the apparent length, cut an arc. This I have explained number of times. So easy. Now this is the final solution. Okay. So when the axis inclined at some degree to VP also, that is 30 degree, beta you will get 45. That's standard value. So next comes case 3. So case 3, when the axis appears to be inclined at 30 degree, directly you can take, move and rotate such that VO is on 30 degree line. Then you get the solution right away. This is the final front view. Again, here is the observer, the base surface is nearer to you than apex, then base surface is visible, boundary is dark, crossing line bends. So you can try it number of times. You take the final view and do it. Now, one may say you take apex towards observer. Why always base towards observer? Yes, if in question the statement is there like base is towards VP or apex towards observer, you can also have alternate solution. See here, the projection and all, same procedure you have to follow. And here, this is dark, base is dark, if that is towards observer. Here it is not dark. Why? Because base is away from the observer. In that case, how do you decide base is away from observer or apex? Now you check for V and O. You draw two lines, horizontal lines. Whichever nearer to you, it is nearer to you. Is this one is away from you and this is nearer to you. And if it is ulta, then it becomes here. Here O is nearer to you, V is away from you. Definitely O base is visible. So here also Same thing, this is other way around, base is away from you, base is not visible. Now let me complete here so that you can get some idea. So select this boundary. See, the procedure number 1 is check for the visible key surface, dark all the edges. Here if I look at this, there is no visible key surface because affix is there, only one key surface that is away from you, it's not visible. So skip that procedure. Go to next procedure. What is next procedure? Boundary lines dark. Select all boundary lines. Select all boundary lines. Yes, these are boundary lines. Keep that dark. Let me again use some color so that you will get a clear idea. Again magenta only. Okay, and this one little bit thick so that you can follow. Actually it is 0.5 final. Now let me take this. Okay, now boundary lines dark. Then invisible key surface edges other than boundary lines are dotted. So this one AD and DC are the only two edges which are not visible because boundary lines are the common line for the slant surfaces as well as the base. So that is taken care by the boundary line. You need not analyze that. So now let me make these two. Let me make these two invisible or dotted. This is for explanation purpose only. Some colors I am giving. Yes, normal, black and white. Let me give blue for this invisible key surfaces. Okay, blue surface, dotted line. Okay, anyway, it has come, no problem. Now, let me select that. Yes. See, what is this blue color is representing? The edges of the base which is not visible, uncovered by the boundary lines. Suppose that these are also happens to be the dotted line, but they are common for lateral triangular face or slant face and the base. That's why it is retained. It is visible, boundary lines. Now, what about this line DV? Here, neither visible surface or invisible surface reference is not there. Okay. So what you do? You can think imagination, since this is away from the observer, this is not visible, this is also not visible. Or you can simply say invisible bends. DV is not visible because it is bends. Because any point joining three lines, two lines are already dotted, this also dotted. If two lines are dark, then the next one is also dark. See, again we have done that job for the previous problem. These two are dark and one more line joining that also dark. So that is how you can analyze. Okay, now this must be dotted. So the procedure wise, the farthest item from you is best, but if it leads to confusion, then only you have to sort out in this way. Okay, now you can complete this particular view with no, farthest point only, just for reference. For understanding purpose, I am keeping this. Say here, I will review this. So here, if you look at this, the base corner D is away from you. So that is not visible. Any number of lines joining that also not visible. Yes, that it comes to that only. Now, what about this line? This is BV. BV is crossing the invisible surface. Invisible surface, visible line. So definitely, or can just check crossing line. Okay, crossing line always opposite in nature. Select this and make that dark. So it's very clear that the farthest item from you can use always. If there is any doubt or confusion, you can always use this key surface method, which is always clear-cut method, no question of committing mistakes. Okay, so that's how you can get. See, this is the edge, which is crossing line. Okay, this is crossing line. Now, this is how you can complete the solution. See, I have this boundary lines dark and these things must be dotted. So again, this is stepwise reference for key method. Then Yes. With axis, I represented the axis. So this is how you can complete the pyramids. It can be any type of pyramid, pentagon, hexagon, square, triangle. Same concept you have to use. But the thing is, you have to check for whether you have to find beta or not. For which case you have to find beta or not. So here, whether it is basis near the observer or away from it. Normally, you take by default basis towards the observer, then work out. Okay. Otherwise, as per the requirement of the question, you would do it. Now, in future, we will work hexagon problems and also cone and cylinders in coming sessions.